Now we're going to learn about a concept known as linearization. And the kind of big idea behind linearization is that it's easier to plug a value into a straight line, because you'd just be multiplying and adding things, than it is a more complicated function. So for example, it's much easier to plug 2.1 into f of x equals 3x plus 5, right? Because you could do 3 times 2.1, which we can do, plus 5, than it is to find the square root of 2.1, to plug it into the square root. So why that's even important is that we can approximate complicated functions using the tangent line, using a straight line. And then we can use that line, we can plug in values to approximate it, to get something close. Okay? So this says let f of x be a function at a f of a, and a f of a be a point on the graph. So we want to find the equation of the tangent line. So this is something you've actually known how to do since Unit 3. So if this is our function, this is a f of a, then if this is our tangent line, the slope of that is f prime of a. So the tangent line, well, we'd use this slope and this point, so it'd be y minus f of a equals f prime of a times x minus a, using point slope form. Now what we're going to do is put this in y equals mx plus b form. So we'd have y minus f of a is equal to f prime of a times x minus okay, sorry about that. We're not actually going to solve it all the way out, because that would look pretty complicated, and we don't need to make it look that complicated. We're just going to get y by itself by adding f of a to both sides. So we'd get y equals f prime of a times x minus a plus f of a. So that's really the equation for this green line. Okay, so that's called our linearization. We're going to use this line, so L of x, the formula is f prime of a times x minus a plus f of a. And what this means is that you can use this to approximate, let's just say, f of d for d near a. So let's say a was, 2. Then you could approximate, say, 2.1 by plugging 2.1 in for x. Okay, so this linearization is actually what I wrote right here. We say the linearization is f prime of a times x minus a plus f of a. Okay, and that's the formula we'll be using to approximate things.